All right, so up here on the board, we've got a basic illustration of what you as a paramedic student should know about the Krebs cycle. Now, if you take a look at your textbook or any other textbooks out there, there is a lot of stuff out there that can be really confusing for students. You know, they talk about other cofactors and the coenzymes and all that stuff, and they use all these abbreviations and acronyms. We're not really going to go into that because that just confuses a lot of students, and sometimes it confuses me as well. So, but it's important to understand that in order for the cells to have energy and their body to have energy, we need to create energy through the cellular respiration process. And the best way that our body gets energy is through the breakdown of glucose. Right? And that breakdown of glucose, as you know, is called glycolysis. Right? So we have glucose in our vessel, right? And so we have an extracellular space, intracellular space. And so this is my crude representation of what the cell looks like, okay? So most of the energy production that occurs in our body occurs in our mitochondria. But it first starts in the cytosol, you know, the cytoplasm within the cell. Right? So glucose is a big molecule. Okay, it's a big molecule, and it needs help getting in the cell. And we have things that help it get in the cell, but once it gets in the cell, it can't be utilized until it's broken down into something called pyruvic acid. And pyruvic acid is a smaller molecule that comes from glucose. Right? So it gets broken down. And when that pyruvic acid gets broken down, we create 4-ATP. But in order for that to occur, we need energy. All this occurs in the cell as an active process, so we need energy. So the cell always has 2 molecules of ATP in its reserve to start the process of breaking down pyruvic acid. All right, so pyruvic acid is broken down and we create 4-ATP. All right? So we get a net gain of about 2 ATP within our cell. All right? So that pyruvic acid is broken down, it's smaller, it can enter the mitochondria. Okay? The mitochondria, as you know, is the powerhouse, is the electric power plant of our cell. And so that's where we get most of our energy. Right? So we need to break down the pyruvic acid to get in the cell, and this coenzyme A, breaks down pyruvic acid. Right? And this is where we get most of our energy. So when we come over here, again, this is a beautiful representation of mitochondria. This is the mitochondria right here blown up. Right? So this coenzyme breaks down this pyruvic acid. And the key to this is we also need oxygen. It needs to be aerobic. Okay? We need to have oxygen present. All right? So along with coenzyme A, we have another coenzyme called acetylcoenzyme A that helps break down pyruvic acid and starts this whole cycle, this TCA, or the tricarboxylic acid cycle, or the citric acid cycle, or also known as the Krebs cycle. It doesn't matter. This is the Krebs cycle. Right? This process, with all the other coenzymes and the cofactors that we have, creates energy. Okay? Synthesizes energy from the breakdown of pyruvic acid. Right? And we have 2 revolutions of this cycle per molecule, and we create 2 ATP. Right? And you're like, well, that's not a lot of ATP. Well, here's the cool thing about this. As this process is through, we keep breaking down, we start transferring electrons. Electrons is where the stuff happens. It's where everything occurs. And so we move electrons back and forth. And as we're moving those electrons back and forth between these cofactors and these other coenzymes, we create a lot more molecules of ATP. In fact, we create a total of 32 ATP molecules through something called the electron transport system. Right? This is where the bulk of the energy occurs. It's through this electron transport system. So we get a total of 32 ATP out of here. We get a net gain of 2 ATP in the cell, and we get 2 ATP molecules from this initiation of the Krebs cycle. Right? So we get a total of about 36 ATP produced within our cells. 36 molecules of ATP per molecule of glucose. And if you remember what I said too, oxygen is important. This is aerobic respiration. This is aerobic metabolism if you want to go that far. If we don't have oxygen present, we become anaerobic. All right? And if we don't have oxygen to break down this pyruvic acid just starts to settle. It starts to accumulate. And accumulation of pyruvic acid creates a buildup of lactic acid. Pyruvic acid converts to lactic acid, and as that lactic acid builds up, we create other problems within the cell. It becomes toxic, and our cells cannot make the energy that it requires. All right, so you're probably wondering, okay, why is this important to me as a paramedic student and as a practicing paramedic when I get out there in the street? So understand, our cells need energy. And so you may run into populations out there that they don't have the energy that they need. But we have ways to treat that. We can give sugar, we can give glucose, we can treat with fluids. Right? And if we treat with those things that you're going to learn about, you have a direct effect on your patient's outcome. The reason for that is because you understand what occurs within the cell.